Welcome to the Lattice Development Conference 2024. My name is Karl Wachswender, and today I would like to share the topic Automate Solution Stack with you, how this aligns with the industrial trends and how you can use this in Industry 4.0 solutions. Yeah, the overview, the speakers for this session. So my name is Karl Wachswender. I will go a little bit deeper in the next slide on my intro. Roland and Balthasar will cover the El Camino topics. Balthasar will give you a very deep dive on the industrial Ethernet, and Roland will give you a short overview on the El Camino side. So again, welcome to the session. So my name is Karl Wachswender. I'm a senior principal system architect in Lattice, joined Lattice in 2021, and I'm working in the industrial segment worldwide. Lead development and also the partnership between industrial partners, industrial FPGA solutions, and build up a strong network around our FPGA solutions. Work very close with the channel and also ecosystem partners and standardization like safety and security. I hand it now over to Roland.
Thanks, Karl. It's great to be here on behalf of El Camino, together with my colleague Balthasar. My name is Roland Neumüller, and I'm the CEO, Managing Director, and founding partner of the El Camino GmbH in Germany. We have a team of more than 20 highly experienced and qualified FPGA and ASIC engineers. I'm myself responsible for sales, marketing, and business development. And in fact, now since more than 4 years, we have a very strong partnership relationship with Lattice Semiconductor. And related to the topic of today, we have developed solutions for Lattice in the area of industrial Ethernet, and we are supporting these solutions. Let me now pass on to my colleague Balthasar from El Camino as well to introduce himself. Balthasar.
Thank you, Roland. So my name is Balthasar Wagenhuber, and at El Camino I'm working as a senior solutions architect. As a hardware engineer, I bring over 30 years of experience in industrial design, including working with FPGAs since the early 90s. Before joining El Camino, I supported various semiconductor companies, collaborating closely with their customers and distribution partners. This work was focused on new product introductions, design-in processes, and field application topics. But currently I am supporting Lattice Semiconductor with Ethernet-based industrial control setups for evaluation and testing of Profinet and EtherCAT field bus devices. So thank you, and back to you, Karl.
What we will cover today is in the agenda a little bit overview on the industry 4.0 or IoT needs and challenges. Then the difference on the industry 3.0 to 4.0. Then trends on the connectivity, security, and the AI side. Then a short update on the Automate Stack 4.0, what we have released today. And then we will jump over to the El Camino implementation. And then we round this up with other solutions from Unlock Device and XOR, a little bit AI solution overview, and then I will give a summary, and then we have the Q&A session. Let's jump into the needs and challenges of the industrial IoT systems. So one industrial trend, and I think that's the biggest one that I have seen the last year, is the energy efficiency and reduce CO2 emissions. So that's the goal from, I think, every country. On the motion side, we have, and there are 3 quotes and from different customers. The one hand side, Asia is growing over 40% in this electromotors. Second, in the European US side, we have new government rules. We need to build higher efficient motors. And then last but not least, the electrical motors goes more or less hand in hand with the country consumption of energy. And on the other hand side, from the energy side, on the grid side, When you're looking to North America, the terms, or if you're the wording behind the terms is distribution energy resource management system, includes now more and more renewable energies. On the other hand side, we need a very stable grid in the different areas to have the motion or the motors up and running. And last but not least, what I said at the beginning, Asia Pacific is the fastest growing market and also consumes a lot of energy there. If we double click on these trends, so to get better control over systems, you need more connectivity to read more sensors, to get more sensors into the calculation or into the control loop. We have started years ago this industrial protocols or some customer protocols. There are more or less some names in this box from EtherCAT, Profinet, PowerLink, Profibus, and Ethernet IP and Modbus. But that gets more and more translated into a TSN solution or a single pair Ethernet. So we try to convert, or the customer try to convert this into a IEEE standard for real-time implementation, and OPC-UA and TSN supports this IEEE needs and offers a lot of solution to the customer. So connectivity is one trend what we need to address. The second one is workload consolidation or virtualization into higher compute units, that we get the sensors not connected direct to a PLC, get connected more to a virtual PLC. For this you need a real-time control in the servers or in the edge compute. For this you need higher performance FPGAs, and we have there, for example, the Avant PIC-Chain to have workload consolidation or virtualization of drives, for example. And last but not least, and you see it on the right hand side, it's a government regulations. What you have, what I said from the IA4, we are seeing now IA5 efficiency standards for motion control. We have the security topics, what the European have signed on the Cyber Resilient Act, and last but not least, the safety implementation. How can we address this trends with our solution stack? Automate stack is a solution to accelerate development for the factory automation application. What we can cover in this Automate stack is robotic workloads, synchronization of motors, main node and sub nodes communication, multi-channel motor control implementation. We have predictive maintenance and a real-time network in the back. So this means we can get from a motor controller over real-time, over AI workflows with predictive maintenance, a complete robot. We demonstrate this in our demo cases on our AMR, that we use the Automate stack for the EMR drive applications, and we use there in the back Ethernet real-time communication with a multi-memory controller and with predictive maintenance. If we double click on this Automate stack and align this with this industry for the zero trend, the technologies what we have today in the factories. So if we look back, Industry 1.0 was the steam-powered implementation, and maybe you have seen some picture on this side. Moved then over the mass production, automation, and then up to Industry of Things and real-time networks and cyber-physical systems. So in this Industry 4.0 implementation or includes IoT, what I said, IoT, industrial Internet of Things with real-time communication, cyber-physical systems, and they are used in smart factories, Industry 4.0, or the smart manufacturing. Cloud computing is a key topic what we have. or cognitive computing, what we have, and a big feature in this industry for this year, what is coming up is AI or AI at the edge, that we have the AI technology in the sensors. If we look into the ISO 95 model and how we can overcome the challenges what the customer has with our Lattice solution, on the one hand side you have the different layers and the deterministic implementation what you need. That is one challenge. The other challenge what you have is the power consumption or the thermal power what the device is more or less produce during the downtime, and we have 24/7 downtime. So this means in the layer 0 near to the sensor you need a very efficient implementation if you would like to have AI or communication or some control loops in a very deterministic implementation with very low power consumption from 500 milliwatt. Very good workload for FPGAs. You see it there on the right hand side. The yellow side is the FPGA workload, the blue is the CPU. We have there a lot of Nexus implementation up and running, and Nexus gives us more or less the low power implementation for the very efficient power consumption level on layer 0. If you look one layer up, same very deterministic implementation with a limitation of around 3 to 4 watts, and we use the FPGAs in PLCs, switches, drives, or in gateways to have real-time communication, to have edge AI implementation, or have security. If we go up over to L5, the workloads are running more and more on the CPU side. Very easy to program, very flexible to program, but the control path will stay on the FPGA side for security, for power control from servers and other workloads, what you have in the back from CPUs. So you see from the lowest level, very deterministic implementation aligns with our Lattice FPGAs, special Nexus and Avant. And if we go up, all the security and control features with our MachXOs are very aligned with the workloads. I said now 3 times AI workloads or the workload consolidation or Industry 4.0. So what we are seeing is in the industrial edge AI side, 2 or 3 different implementations. So on one hand is NVIDIA with our bridge implementation, what you can find on our website, to control multiple cameras and have a very low latency communication over 10 gig to NVIDIA Jetson box. That is used, for example, for control and inside data. Inside data is handling the AI workloads. We can control the PLCs. We have the AI machine learning implementation on the inside data flow, and on the FPGA side we make the bridging between camera and the connectivity and a very deterministic implementation. If you like, you can complete the stem with fuser and with security. That is industrial AI at the edge. We have complete concepts with our NVIDIA bridge device. On the other hand side, we have other solution with multiple industrial Ethernet topics on the left hand side. We have then TSN or other protocols up and running in our FPGA and can bridge this industrial Ethernet over acceleration processing into, for example, in ORAN or into other CPUs over PCI Express. So multiple field bus interfaces over a smart NIC like this way to have then a virtual soft PLC or control in, for example, in the ORAN implementation up and running. So that's a workload consolidation to bring all the different workloads like connectivity, protocol acceleration, buffering, everything together and have multiple streams to the sensors, and the benefits of the value is the connectivity, deterministic, and the same on the fuse and security side. Industry 4.0 combines all the workloads what I have said before. This is on the one hand side AI, analytic, build a digital twin. And there replace the same values, you have there the FPGA values in a similar way. Data in, deterministic user security implementation. We can control multi-camera solutions or the multi-machine systems in this area and have multiple control paths up and running. That's a AI workloads what we have up and running with our customers, and we can give you also on this side a lot of reference designs. And last but not least is the security trend. So the European Cyber Resilience Act is a big investment from the Europeans. Get in place in 2027, what I have understood on the SPS show last week. And you see all the topics what you need to have, your documentation, recovery plans, but you need also to have a bug fix in hours or in 24 hours for the solutions. So what we have done is to have a lead implementation up and running with the BMW InnoHub in Dingolfingen in Germany. We built a reference design, and this reference design shows you OPC-UA security communication with key exchange, with onboarding, with offboarding over an ARM CPU, and also a root of trust with a platform firmware resilient implementation. So this means you can control the whole security lifetime from your devices over industrial standard OPC-UA down to our MAXO devices and have the whole key exchange or many signatures or whatever you would like to do in our root of trust device. I have spoken now 3 or 4 times over the Automate stack. So now you see the Automate stack. So we have 5 layers of Automate stack. It's hardware topic. From the hardware side, we have multiple eval boards. You see from the one down to a small Certus NX or the Certus Pro, you have different implementation there. You get the IPs for an Ethernet connect. We have now Profinet available. FreeRTOS implementation for soft RISC-V implementation, and also the AI topics. On top of this, we have then different software tools from the software toolchain, and then libraries for communication like MQTT or the OPC-UA. Running then under RISC-V with a hardware acceleration on AI if you would like to do this. From the reference design, you see multiple reference design are possible from hardware security over industrial Ethernet communication with FreeRTOS, predictive maintenance or the multi-access controller with FreeRTOS. And then in the top, we have then consulting partners that can help you to bring this into different end application, robotics, PLC, cyber resilience system for the security side, and in the future also safety. And as I said before, on the FPGA side, for the Automate stack, we are using the low power FPGA technology from Lattice. We have up to 75% lower power consumption with the same workload as our competitors, and we can offer very small form factors for the industry. We have the security topic or zero trust security enabled on the devices. We have a state-of-the-art performance for the industrial side. Don't forget the low SER or single event upset side and the fast recovery time if anything happens for safety topics. And last but not least, we have an industrial lifetime alignment up to 15 years, and you find all this information on our website.
Thanks, Carl. We'll be talking now about our real-time connectivity, respectively our industrial Ethernet solutions. Before we go into the technical details, I would like to introduce quickly our company, El Camino. El Camino is a design house for programmable logic and functional verification. El Camino was founded 25 years ago by former Altera employees. Wolfgang Löwer, my CTO colleague, and me are managing the company now, and we were also two of the founders back in 99. As I said before, we have more than 20 highly qualified FPGA ASIC engineers, and our headquarters is in Mainburg, which is south of Germany in the beautiful Bavaria. Our expertise is in FPGA design, consulting, training, optimization, and we also build custom FPGA boards with PCB design and manufacturing. We also develop IPs and integrate them into bigger designs. The second area of expertise in our company is design house for functional verification. So this is the functional verification part. And functional verification means, in our case, ASIC verification, and we're using here the E language and system Verilog. And UVM, Universal Verification Methodology, is the keyword here. Now let me talk what we specifically do for and with Lattice. We have a partnership since mid 2020 doing FPGA designs and conversion for Lattice customers. We do consulting, support, and provide technical training. And specifically for the topic of today of industrial Ethernet, we are working closely with Lattice, providing a kickstart for new customers. We can do implementation and integration for the various industrial Ethernet protocols. And together with Lattice, we develop demo reference designs. We can give you application support. And we're also a member of the EtherCAT technology group, ETG. EtherCAT being one of the industrial Ethernet protocols. Now, for a deeper dive in the technical details of industrial Ethernet, I would like to pass on to my colleague, Balthasar.
Thank you, Roland. I want to start with some essential information about the Ethernet standard. This slide illustrates the fundamental concept of the Ethernet protocol. The basic frame structure on the bottom of my slide has been approved by the IEEE in 1983, and it is unchanged since that time. Preamble patterns and the start of delimiter pattern are indicating a subsequent Ethernet frame. Starting with the 48-bit MAC addresses of the communication partners, destination and source addresses are marked in blue, followed by an Ether-type field. Then the client data is transferred. This section, marked in yellow, contains the data according to the higher level protocols. At the end, a correct checksum indicates a frame with no bit errors and ensures error-free data transmission. Now let's have a closer look at some upper layer protocols mandatory for field bus communication. For this, the Ether-type fields that I have highlighted in orange is key. It effectively acts as a protocol identifier, indicating which higher level data is encapsulated as client data within the Ethernet frame. Type values are unique and are assigned by the IEEE. An Ethernet device that is addressed by the destination MAC is first checking the Ether-type value. Then there are two options. If it is a known and supported protocol, the frame is received and processed on a higher level. If not, the frame is discarded. I have added a few Ether-type examples used for industrial field bus communication. First, 88A4 identifies a frame with field bus data for EtherCAT that has been defined by Beckhoff. This protocol includes EtherCAT header and one or more EtherCAT datagrams and has to be processed according to the EtherCAT specification. EtherCAT is using this protocol layer for real-time processed data, configuration and diagnostics. Next one is 8892. It identifies a frame with field bus data for Profinet. Profinet was initially developed by Siemens and is now supported by the Profibus and Profinet International Group. This protocol includes a frame ID, real-time I/O data, a cycle counter and a status field, and has to be processed according to the Profinet specification. Profinet is using this protocol only for real-time processed data. For configuration and diagnostics, Profinet is using higher level protocols based on the well-known IP4 protocol layer. CC-Link, for example, is using only IP protocols and its mandatory services for real-time data and configuration. So next topic is the mandatory IP4 services. These are, for example, the 88CC. It identifies the link layer discovery protocol or LLDP defined by the IEEE. It allows network devices to advertise their identity and capabilities to other devices on the same network. Profinet may use this protocol for network diagnostics and topology checking. Next one is 0806. It identifies the Address Resolution Protocol or ARP. It is defined by the Internet Engineering Task Force or EITF. Its purpose is to map an IP address to a physical MAC address on the same network. This address resolution is mandatory for any kind of Ethernet communication utilizing IP addresses to discover the MAC address associated with a specific IP address. The Ether type value for IP communication itself is 0800. It identifies the Internet Protocol defined by the Internet Engineering Task Force or IETF. All well-known Internet services are encapsulated here. For example, UDP IP or TCP IP. Profinet is using this protocol layer as well, but only for network configuration and diagnostics features and not for real-time data. So let's go to my next slide. Currently I am focusing on the hardware components and software tools for evaluation and testing of Profinet and EtherCAT I/O devices implemented on the Lattice CPNX FPGA family. On this slide we see the picture of a newly designed evaluation board specifically optimized for industrial communication. This board has been designed for industrial grade Ethernet, for simple digital I/O control applications or more complex use cases like motor control applications. The FPGA enables support for protocols like Profinet and EtherCAT or other industrial field buses using Ethernet for data communication. For EtherCAT, 2 Ethernet ports are mandatory for one I/O device. These ports are placed on the right side of the evaluation board. The board includes essential components required to set up FPGA-based solutions for various industrial field bus standards, especially an industrial-grade FPGA from Lattice Semiconductor and an industrial-grade PHY component, or more PHY components for sure, from our partner Analog Devices, solving the Ethernet physical layer interface. So it provides a perfect platform for development, evaluation and testing, fully documented with schematics and a part list of all semiconductors used. With its industrial grade design, it can serve as a reference to assist users in designing their own custom industrial boards. An onboard USB programming interface enables the FPGA configuration and software download, eliminating the need for an external programming adapter. 2 PMOD digital I/O ports can be used to extend the board features with external test headers and peripheral modules. So for more details on that, Let's go to the next slide. On top of this slide, we see test headers and various modules that can be connected to the peripheral module interface connectors PMOD0 and PMOD1 on the evaluation board. I'm showcasing useful PMOD examples we recommend for testing of user IOs on field bus devices implemented on the evaluation board. So PMOD0 and 1 connectors can be used to make testing easier or even to add complex features like, for example, a control board for a brushless DC drive. Recommended examples on this slide are test headers that provide access to all connected signals with test points not available on the main board. A digital output LED module that enables direct monitoring the status of digital outputs through LED indicators. A digital input switch module that allows users to easily set the status of digital inputs, and a E2C memory module that can be placed on top of the test header module. This can address memory constraints of the evaluation board by providing non-volatile I2C storage space for field bus parameters. The FPGA configuration options are shown on the bottom of this slide. The previously introduced new evaluation board can be configured as Profinet I/O device or EtherCAT sub-device. The Profinet I/O device configuration on the left is based on a system reference design from Lattice Semiconductor, utilizing an Ethernet MAC IP core for the fundamental Ethernet Layer 2 communication, a RISC-V microcontroller IP core, a free RTOS operating system along with a free TCP IP stack, a Profinet I/O software stack from our partner RT Labs in Sweden, and finally an example software for a Profinet I/O device application handling the digital I/Os. All necessary FPGA and software development tools for this setup are available from Lattice Semiconductor. Complete test setups for Profinet and EtherCAT solutions are available based on the configurations discussed on my previous slide. Each setup is fully documented in a user guide with a complete list of hardware and software components used, including ordering information, product and download links to the hardware datasheets and the software with installation guidelines. This ensures that each setup can be easily replicated on the customer side. They are designed for quick evaluation for hardware and software development and for testing, or even rapid prototyping of industrial distributed I/O devices. And they can also serve as a framework for building small to mid-size industrial control systems. On this slide, I'm starting with the Profinet setup. It allows engineers to quickly assess the capabilities of a Profinet I/O system and to get familiar with, for example, the Siemens TIA Portal engineering software running on a Windows PC or laptop. This engineering tool is widely used in the industry for network configuration and PLC programming. The Profinet user guide comes with an example project, but also provides a step-by-step description on how to set up a TIA project from scratch, and will guide you through other useful features, for example, on how to configure the evaluation board FPGA logic and software, how to scan the network for accessible devices, how to set the IP addresses and names of Profinet I/O devices, how to start with the example project that is ready to test basic Profinet I/O functions, and more useful features. Now I come to the details of the hardware components used in this setup. First, the Siemens SIMATIC S7 programmable logic controller is a compact PLC device designed for small to mid-sized automation. As a Profinet I/O controller, it manages communication with distributed I/O devices over a Profinet network, ensuring real-time data exchange and precise control. The S7 also supports running PLC programs for testing and demonstration purposes, making it perfect for system development, validation, testing, and troubleshooting. Next, a Phoenix Contact Profinet I/O device is used as a known good device, essential for setting up the network before adding any new Profinet I/O device. This ensures the proper functionality of the existing I/O controller and Profinet network, enabling us to identify, analyze any issues that may arise during software development. Next, Ethernet network tab serves as a crucial hardware component inserted in line within a network link to capture real-time data traffic with the Wireshark tool. Wireshark can decode Profinet I/O packets and enable a detailed analysis of parameters like cycle time, status information, diagnostics data, essential for troubleshooting and optimization of the Profinet I/O communication. The last component of this slide is our evaluation board, as already discussed in detail.
Thank you, Balthasar. And now a little bit deeper on the secure connect and motion control device, so analog device, and Lattice made a decision last year to work together on a flexible, secure, low power, high performance motor control platform. And this was the board what Balthasar have shown to you. And that's available. So we have sold the first boards to the customer. We will respin the board, and you will see in the next 8 to 10 weeks a new board. With the same components on it, with the same features, only some bug fixes on the board, and we will show multi-motion controllers on it. We will show different Ethernet protocols like Profinet or TSN or a single pair Ethernet on these devices, and EDI had also a demo up and running on the EI acceleration for monitoring a solution on the edge. So edge computing or the edge EI implementation was up and running on the card, and this shows the flexibility of the FPGA. So from communication over security over EI workloads, everything could be run, or could we show a demo on this board. And the partnership is between Analog Device, Lattice, Aero, and our development team, or the Aero's development team was InfoChip. So you see this on the board. Another example is the EXA application. You find this with the security kit. So what we have on this is a real-time control unit on the FPGA with ARM CPU. On the one hand side, we have the ARM CPU covering all this communication, Wi-Fi, all these housekeeping topics, cloud management, and communication. You can show also control as a service, motion as a service, or HMI functions. And on the other hand side, we have a FPGA on the board, and this FPGA makes the real-time communication for Ethernet, real-time Ethernet, domain controllers, or closed loop systems, or last mile IoT systems, motion control. So you see, you have multiple functions what you can control with the FPGA on the board. In the middle, you have also the security feature with the root of trust for the CRE up and running, and that was the first SOM module with all the features on the one hand side, cloud communication, on the other hand side, the real-time communication combined with a root of trust device from us. If we look, you see there a SOM module on the right hand side. Nearby is a 2 euro coin. That is the size of the implementation. On the module you have a FPGA, you have the CPU, and then you have the root of trust. What we can do with the SOM or with the SOM Micro SO10 to have industrial Ethernet security, we can go after platform firmware resilient implementation after the standard from the NIST to have everything booted up in the right way. We have the scalability to detect firmware updates or respond for firmware updates in nanoseconds. And the root of trust have the control over all the power rails, and if anything happens, they can fall back in a PFR mode, and this PFR mode more or less turns off the power and reboot the whole system in a safe way. So with these features, we enable a safe protection. So we are booting the system up over the root of trust system, control all the firmwares, and enable then the boot up of the different CPUs or FPGAs. With this, we have the root of trust, and we have a trusted environment after the boot. If any updates happens and we think we have a high risk, we can immediately turn off the whole stuff or protect more or less the flash or reconfigure the flash and boot from other image. The important stuff is the real-time detection that's done over monitors, what we have all around the CPU and the ECP5s are connected to our root of trust. And last but not least, we have the safe recovery. This means if we really have attack happens, they can reboot out of the box and come up with a golden image, and this golden image can reflect, for example, hey, I had an attack, I have a problem, help me customer, and response to some special needs. So everything implemented on this module. If you would like to have a security kit, we will work on, or the reference design on the security side will work on this sub-module, and you can learn more on our website. So Automate Stack solution, you can address the trends what we have, real-time communication, deterministic control, motion control, what you have heard before. But you can also transform your factory with our Automate Stack to the next generation of Industry 4.0. This means predictive maintenance, a complete decentralized system if you like, and then you have all the communication to the cloud over OPC-UA plus the security. And if you need help to get deeper into this, El Camino is one partner that can help you, and Automate Stack is available on their website. You can look into this, and if you have any needs to get trainings, please contact us and ping me. So last but not least, the frequently asked questions. The first question, could FPGA support different industrial Ethernet? Yes, definitely. We can support all the different kinds of Ethernet protocols or the industrial Ethernet protocols. We have started with single pair Ethernet. We have started on TSN. We have Profinet up and running. So, and you will see more and more releases over the next year, 2025. Which industrial stacks do Lattice use? So we are using a industrial Ethernet stack from RT Labs. RT Labs supports all different kinds of industrial protocols, and we are aligning our hardware with the software from them and give a complete reference design to the customer. El Camino support model. I think the best way is to contact El Camino direct. What I have learned over the last year, El Camino can support all kinds of FPGA or hardware implementation or software implementation. So it starts from verification, from concept down to complete end-to-end development. But the best way to get a better understanding is to contact Roland or Balthasar. Do we need an embedded processor to assist the RT communication, real-time communication? So it's easier. So we are using a RISC-V between 100 and 200 megahertz, depends on the FPGA technology, and run there the software stack from RT Labs, and this handles all the protocol stacks what you need for the real-time communication. Last but not least, Cyber Resilience Act is a must in the European Union in 2027, what we have understood from the last meetings. It's aligned with the CE certification, and the customer need to look into this to get the implementation up and running. As I said, we have a complete platform firmware resilient implementation. We can use this for CRA, and please look at the website and you can copy and paste the references. So this brings me to my end. Thank you for your time. Thank you for the patience. And if you need more information, ping your Lattice salesperson, FAE, or send me an email. Thank you for your time. Bye.